emissions, and we find a way to capture that emission and store it in some way.
Surprisingly, concrete can be a big part of the solution.
So concrete's actually being manufactured where CO2 is being pumped into the concrete mix, and then the concrete is cured, and so essentially locks that carbon emission into the concrete itself. And so that is one example of a way in which to sequester carbon.
The chemistry works like this. Carbon dioxide reclaimed from industrial processes such as fossil fuel burning is pumped into fresh concrete during mixing. It then reacts with calcium ion in the cement to form calcium carbonate, a mineral that increases the compressive strength. And the carbon dioxide has now been transformed into an inert form that can never escape into the atmosphere.
There's a lot of aspiration that this could be a way in which to reduce our environmental impacts. But because these technologies are just being created and implemented, we need to understand further how that will perform in the long term.
In 2020, the world's population reached 7.8 billion. We now have more mouths to feed than any time in history. To meet this need, we've used chemistry to enhance our fertilizers, with unintended consequences.
So our use of synthetic fertilizers, which is an amazing development that has enabled the growth of human populations and well-being of people around the world, producing more food from the same amount of land over decades, is a kind of miracle. It has also caused the explosive growth of algae that choke waterways and create vast dead zones in our oceans from agricultural runoff from the use of synthetic fertilizers.
One critical fertilizer ingredient is phosphorus.
So like water and carbon and oxygen, phosphorus is essential for food production. So basically, without phosphorus, you can't grow food anywhere in the world.
Phosphorus is the chemical backbone of DNA. Every plant, animal cell, and living thing needs phosphorus to thrive.
We get our phosphorus from the food that we eat. Almost all cultures throughout time were able to recycle organic waste, whether that was crop waste or human excreta and manure, back to the soils for food production.
Recycled human waste was a natural fertilizer that gave plants